Happy Monday! And the last class of February. Time certainly flies. We are, 2 weeks away from spring break, too, which is exciting. That sucks. I don't miss those days. My wife does, but I don't, so it's a win. Plus, my kids have preschool, so it's a win. Video games, here I come. Wednesday, we looked at Introduction to Polynomials, right? And a very, very easy day. We looked at leading term, leading coefficient, degree, constant term, and then end behavior. What we're going to look at today is dividing polynomials. So without actually saying it, we're simplifying rational functions, right? But we haven't studied rational functions yet, so didn't use that terminology. You should recall from basic arithmetic. Why is that computer on and not shut off? Whatever. There's this useful little thing called the division algorithm. What it says for every integer m and n, there exists unique integers q and r such that m is equal to n times q plus r. Where r is between 0 and n. Q is called your quotient, r is called your remainder. Better not scream, take me.
The Q is called quotient, right?
Yep. And r is the remainder.
Yeah, that is 0.
0 less than equal to r less than n. With slight tweaks, we can write this for polynomials. So for all polynomials, f of x and d of x, there exist unique polynomials q of x and r of x, such that f of x is d of x times q of x plus r of x, where the degree of r has to be less than the degree of d.
D of G, or D of G.
Hmm?
What does that say? D, oh, degree. Oh, degree.
No, the DEG? Yeah, degree. Q of x is your quotient, r of x is your remainder. D of x is the divisor. Want to get really into it, f of x is the dividend. Remember that a constant has degree 0. So r can be a constant or polynomial of degree less than d.
R can equal.
R can be a constant. Constant is a polynomial of degree 0. Now, if you take a constant polynomial, call it 5, that has a degree of 0, right? Because it's 5x to the 0. That's why we say it has degree 0.
So on that,
You're probably thinking of exponents, something to the 0 is equal to 1. That's not what we're referring to when I say degree.
so on that homework problem where it was like, tell which ones of these are polynomials.
Constants are polynomials.
So they were all polynomials then.
Technically speaking, a constant is a polynomial.
So 9x squared.
That's a polynomial.
So what's a monomial?
Monomial is a polynomial of a single term.
But they're all still polynomials.
Yes, it's still a polynomial. Right, binomial is a polynomial of 2 terms. But it's still polynomials. So careful not to make noise when I've already seen the chips in it.
See that, I don't know if I'm.
Breaking the golden rule, bringing food but none for the instructor. Results in a 10-point deduction
Wasn't M&M's?
for each offense. Oh, you ask after I say that, so you still get a 10-point deduction.
It's good, it's better than before I started eating.
Mm-hmm.
Counts.
It's the thought that counts. Mm-hmm.
Oh, okay.
This is what we're going to spend today doing, is doing division. Right. Now, you're familiar with division of integers, specifically long division. Right, remember that? Well, you got your bugger. We also have what's known as polynomial long division. And it works pretty much the exact same way. We also have a new technique called synthetic division. However, synthetic division works only on specific divisors, specifically if your divisor is of the form x minus a. And we will look at both techniques.
Synthetic division.
We'll look at both. What we want to do is find quotient and remainder. So we want the q of x and the r of x that are guaranteed when f of x is divided by g of x. So the divisor g of x, it is not of the form x minus a. So technically, synthetic division cannot be used. However, if we're clever, we can use synthetic division. I will do both polynomial long division and show you the clever technique to do synthetic on this. Starting with long division. Divisor goes on the outside. Your dividend goes on the inside. Now here's the game that you play. Look at the first term of the dividend. What is it? So you go, what do you have to multiply 2x by to get 2x cubed?
Squared.
And x squared. Now multiply the entire divisor by x squared. And subtract. First term is guaranteed to cancel out. Left with 6x squared minus 13x plus 5. You look at that and you go, what is the degree of that? What's the degree of the divisor? Is the degree of the divisor larger than the degree of this new dividend? Nope, so we have to keep going. So treat 6x squared minus 13x plus 5 as your dividend now. And you do the same thing. You look at the leading term. What do you have to multiply the leading term of the divisor by to get it? So multiply the entire divisor by 3x and do the same thing.
Now, how did you just, why was it x squared plus 3x and not minus? Because it was 2 times positive 3, 2x times positive 3x?
Yeah. Right, because the leading term is 6x squared.
Right.
So that's why it's plus. If that was negative 6x squared, then that would have been a minus 3x. Right. Negative 13 and 9 is negative 4. What is the degree of that new term?
First degree.
Is that degree smaller than the degree of the divisor? No, so you have to keep going.
Now it's gonna be a minus.
Right? What do you have to multiply 2x by to get the leading term? You're left with -1. Is the degree smaller than the degree of the divisor? It is, so you're done. This up here is your quotient, and that's your remainder. Synthetic. Factor out a 2 in the divisor. It's now x minus 3/2. But can't rewrite this? Like that? So treat x minus 3/2 as your divisor. You'll then have to multiply everything by 1/2 when you're done. That's how you can use synthetic division for this form. So here is how synthetic division works. If your divisor is of the form x minus a, you write your a. So you draw a long enough vertical bar. Next to that now, on the other side of the vertical bar, write the coefficients of the dividend. First term drops down. Now multiplied by a. So 2 times 3 halves. Add them. So 3 plus 3. Multiply by 3 halves.
Well, I'm sorry. Well, just back up a second. Where did that 2 in the lower left come from?
This term just drops down. The first term just drops down. And then multiply by 3 halves. Yeah.
So multiply 6 by 3 halves.
Mhm. So what's 6? What's 6 by 3 halves? You're making this more. What is it? It's 9. Add it to negative 13. Multiply it by 3 halves. Add it. 5. I typically just box that last term because it's important for what we're going to do next. That is your remainder. That last term is your remainder. Now you go. What was the degree of the original dividend? That means the degree of your quotient is 1 less. And these give you the coefficients. And that last term is, of course, the remainder. And notice I wrote Q1. Because we still have to do something. We have to multiply Q1 by a half. Because of factoring out the 2 from the divisor.
But the divisor doesn't get multiplied by a half.
Hmm?
I mean, I'm sorry, the remainder.
No, because of this right here. Only Q of X is getting multiplied by D of X in the division algorithm. Right, so that's the only term that'll be affected, that Q of X. We're going to be doing so much synthetic division on Wednesday. You're going to have nightmares.
You're gonna want us to do it in synthetic division way.
You can do it with long division if you want. Yeah, a lot longer. Is the divisor of the form x minus a? You can't even put it in the form of x minus a, right? Because it's degree 3. This means you only have one choice. You have to use long division. For bookkeeping purposes and to keep everything lined up, if your dividend is missing a term, which in this case it's missing the x to the 4th term, write it as 0 times that missing term. So I wrote 0x to the 4th. It may matter, it may not. In this case, I don't think it matters. I probably could have gotten away with not writing it, and it would have been fine.
Keep it organized. It's, you know where.
Because if I had to multiply, if I would have had to multiply by an x to the 4th, I would have had no term to write it over. And so again, it just keeps it organized. Like I said, in this case, it actually doesn't matter because I'm not going to have to multiply by an x to the 4th. But it doesn't hurt just to write it. Plus, when it comes to synthetic division, noticing missing terms is important, as we'll see. So just get in the habit of always writing it. So you look at the leading term of the dividend. What is it? What's the leading term of the divisor? What do you have to multiply x cubed by to get 3x to the 5th? So multiply by 3x squared. I can now just drop that 0x to the 4th because my leading term will be a 3rd degree, right? Is the degree of the new polynomial less than the degree of the divisor? So keep going. What is the leading term? New polynomial. What's the leading term of the new polynomial? So what do you have to multiply x cubed by to get it? What is the degree of the new polynomial?
Three, it's two, second.
Which is less than 3, so that's your remainder. Easy, right? Just tedious. This just requires arithmetic. Divisor. Is it of the form x minus a? Yes. We can use synthetic division.
Oh, X minus A is.
Yes, has to be x minus a. What is a?
Negative two.
-2. Right, because it's x minus -2. You could use long division if you really wanted to. Coefficients in descending order of the dividend. Dividend is what degree? So the quotient is going to be of degree 2. 2 drops down. Times -2. What is it? Plus 5 times -2. Plus -10 times -2 plus 9. $33 is the remainder. And the quotient is 2x squared plus x minus 12. Which is just so much easier than long division. Where?
The X in parentheses.
Thank you.
Q for quotient.
Thank you.
Don't quite know how Q looks like F.
Well, it's got that dot and that line across
It's a
the
weird
middle.
angle.
I can kind of see the.
Thank you guys.
I mean, maybe if I was doing print, because I write my F's that way in print. That's a lowercase q. No, cursive Q actually looks like this. Looks like a 2. That's why I don't use that for capital Q.
The lowercase q?
No, this is a capital Q in cursive. Because an actual 2 is supposed to look like this. This is how you actually write 2.
Oh.
That's how you're supposed to write it. I should probably start writing my 2s like that because there is a symbol in Calc 3 that looks like a 2 if you're not careful.
Yeah.
6.
Partial X. If you're not careful, that partial looks like a 2. But that's discussion for another day.
Calc 3.
I'll actually be teaching partials tomorrow in my Calc 3, so I'll be doing it tomorrow. What's your major? No, you don't have to take Calc 3. You actually don't even have to. You actually don't even have to take this course
They told me, yeah.
because this course doesn't offer this college doesn't offer college algebra. For business, you just need college algebra and what's known as applied calculus. You don't even need Calc 1 because they're the same course except the business version doesn't have trig. You'll have to take a stat course as well for business. So you'll be over-prepared. I guess it would particularly suck if it was the trig part that kept you from passing, so you don't even need that for business. Like C right up until trig. It's like yes, and then trig is just enough to not make you pass, and you don't even need trig for business.
Well, if you're doing synthetic division, do you have to put a 0 in for the
We'll get there.
power?
We'll get there. Don't get ahead. Don't ruin my party. I don't like people who ruin my fun.
I understand.
I tend to grade them harsher. Divisor. Is it of the form, in this case, t minus a? It is. What is a? Oh, well, that's just sad. Phillies allow the lovely Pirates to score 7 runs.
I like that.
Still won, but a team like the Pirates.
Kind of sad.
I know.
Very funny.
Now, in descending order, coefficients of the dividend. There is no t cubed, which means it has a coefficient of 0. That's why I said you have to be careful. Now what?
15.
So to answer your question, yes, If there are missing terms, the coefficient is 0, so you write zeros out for them.
Just not like -6 at the end.
Then that would be a 0. The only zeros you don't need are the zeros that occur before the leading term. All right, so you don't have to worry about the t to the 6th, t to the 7th, right? Because it's degree 5. -3 drops down. Times 4. Plus 10. Times 4. Plus 0. Times 4.
What's that?
-32.
Plus 15.
-17,
Times 4.
68,
Plus 18.
-50,
Times 4.
-200.
Plus -6. That's the remainder. Quotient. Degree of the dividend is what? Degree of the dividend. P5 is not a degree.
Well, fifth.
5th degree. So the degree of the quotient will be
Oh, you bet, Q. T.
they should be T's, yeah, not X's. I'm just so used to X.
I'm just so happy to trip you up on it.
It won't be the first time I write X instead of what it should be. Yet I guarantee if it was your test, I would have noticed it immediately. I notice the smallest things and then I just can't unnotice them. And it bugs me for the rest of the test.
Speaking of tests. They've been great.
I didn't do anything this weekend. I had a work meeting Friday and then of course the weekend is family time. I'm hoping to have them done by the middle of this week. I don't know if you get an alert when I post a grade on Blackboard. I know Canvas does. I don't think Blackboard even has a setting where I can alert you once a grade posts.
For other classes. Oh, no,
It's probably because it's something it was assigned that you had to upload on the Blackboard. Right.
notifications on Teams, although that's really only for homework.
Yeah, the Teams I know doesn't notify you when I return an assignment. Which is just stupid. Divisor of the form x minus a. What is a? Descending order coefficients of the dividend. So it should go without saying that it's important that you actually write your divisor and dividend in descending order, right, in standard form. Two drops down times a half. -5. times a half plus 6 times a half minus 3. See how nice that was? Didn't make you deal with fractions at all. I won't be that nice on a test. What is the degree of the quotient going to be? What is it? I'm making sure because it almost sounded like 7. That's why I was double checking. If it's 7, we got some problems. Remainder is -1.
Setting provision.
I don't know. I could be really evil and give you a Calc 3 quiz. Can we use synthetic? What is A? In descending order, coefficients of the dividend. Three drops down times -2/3.
-2.
Plus 8 times -2/3. -1 times -2/3. Plus 7 times -2/3.
62.
Plus 2. There's your remainder. What will the degree of the quotient be? There's your quotient, there's your remainder. See how easy this is. With a bit of manipulation, we can rewrite the division algorithm. This is how you would simplify a rational function. Right? So think of it as a mixed number. Okay? If I give you 31 over 3 as a mixed number, that's 10 1/3, right? Which is 10 plus 1 over 3. 10 is your quotient, 1 is your remainder when 31 is divided by 3. So writing it as q of x plus r of x over d of x is essentially writing it as a mixed number. Right? Remember what 31/3 was called? It's an improper fraction. Just like if the degree of your numerator is greater than the degree of the denominator, your rational is said to be improper. That is going to be very important in Calc 2 when you study integration of rational functions. Which you don't have to take, but maybe I'll hack into the system and force you to take it. Especially if I'm teaching it that semester. If I hack into the system, you will. Whether you should be in it or not, it's a whole other story, but I don't care about that.
Obviously, I'm in here now.
Now you're saying you're not prepared for this course? Yeah. That sounds like a high school problem.
So I'm in school for like 6 years.
It's like riding a bike. You never truly forget it.
I'm a little lost.
Definitely forget how to divide a polynomial. Never went through that.
You should have in basic algebra. I believe. Unless they changed that. I know I did it in basic algebra. Again, that was back when the dinosaurs were roaming the earth and computers was still a new thing. Back when computers were just DOSes, there was no mouse. You had to type in all your commands.
And then the Mac set the world on fire.
It wasn't the Mac, it was the PC.
I'm just thinking about the Mac with the, that was the first computer in my house that had a mouse attached. Before that was Apple IICs and stuff.
Was it? I thought Windows did that. I thought Windows is what
Well,
broke that.
probably did then.
Apple set the smartphone world on fire. But I thought Windows was the first PC. I could be wrong. I don't remember. So long ago. I barely remember my daughter's birth, and that was last year. Don't remember my son's birth.
We have a favorite without telling me I have a favorite.
You always remember your first. If you have another one, it's never as good as the first. Something your parents will never tell you. I'm not saying my daughter's not my favorite. I'm saying you remember the first more than subsequent ones.
Yeah.
Because it's your first.
Oh, like the check up on. What did you want with two?
I have to check up on both of them. I'm honestly surprised I haven't had more injury reports with my son. The number of times he bangs his head. We have to write our answer, since it says perform the operation, in that green form. Right, so we still have to find quotient and remainder, but then we have to write it as Q of X plus R of X over D of X. That's the only difference. So instead of writing our answer the way we have it of just Q equals and R equals, it's no different, just a different form. Can we perform synthetic? What is A? What are the coefficients? Carry the 1 down, times -4 minus 2 times -4 minus 24 times -4 plus 15 times -4 15 times -4. What is it?
Yeah, 60.
Plus 50?
60 on my paper and 3060.
I've done that. What is the degree of the quotient going to be? So that operation equals x cubed minus 6x squared plus 15 minus 10 over x plus 4. That was Q. And that numerator was R. See? Same process, you're just writing it differently. Yeah, that's done.
Oh, because, I see.
So if it equals 0 there, the x wouldn't come down, it would just be x.
What about this one here?
Yeah, 0.
Right, so that's 0x, so you don't need to write it.
Or it's technically D of X.
No.
Or D.
Yes, x plus 4 is D of x. It's the divisor.
Separate on.
Well, I mean, there is. It's the 10, but you're writing it.
You don't have to, like,
Over the
divide it,
divisor.
right? You know what I'm saying?
No, because I didn't ask for quotient and remainder. I asked to perform the operation. Right, there might be a problem where I asked just for the remainder. In which case you just write out -10
All right.
as your remainder, right? There might also be a problem where I asked just for the quotient. Then you just write out the Q.
Yes.
So it all depends on what's being asked for. Can we use synthetic? What's A? Mm-hmm.
Oh, that he killed me that one.
It always sounds like my son when he takes a bite of food. Coefficients. Good, you didn't forget the zeros. 2 drops down. Times -3. Plus 0. Uh-oh. Times -3. Minus 17. Times -3. Plus 0. Times -3. Minus 4. What is the degree of the quotient? Honestly, I honestly wish the calc 2 integrals were that easy. Sadly, they're not. Can we use synthetic? What is A? Coefficients. Four drops down times a half. Minus 10. Times a half. Plus 1. Times a half. Which is what improper?
Like a free answer over two.
Minus 1. Degree of quotient. I don't like the way that looks. Multiply numerator and denominator by 2. That looks much better. Any questions? Hmm?
Is there gonna be a fraction?
Oh,
Could we do another example of one that isn't already in the whatever one is?
A synthetic formula. You want to do a long division?
Well, no, like the number one, where g of x was equal to 2x minus, I guess, is that already in there? Well, but then we had to multiply it by 2 in order to turn it into 3 over. You know what I mean? Am I saying that right? Like in number one, we took it from 2x minus 3, and then we multiplied it by half, and then it converted to x minus 3 over 2. And then we were able to do synthetic division.
do something like that.
And then it would be f of x. You have to factor out the 3.
What are you gonna be left with?
It's 1/3.
What is A? Coefficients. Nine times a third. Minus 9. Times a third. Plus 18. Times a third. Plus 5.
31/3.
So what's the degree of the quotient? So you have to divide everything of the quotient by 3. I wrote the remainder term originally. It was over x minus a third. Right. Obviously, then I can write that as 31 over 3x minus 1.
Why did the 16 get the 30?
Everything of the quotient gets divided by 3. Because we factored a 3 out of the divisor.
Two or divided.
Essentially multiplying back through the quotient, yes. Something doesn't seem right. But,
Okay, the quotient gets divided by 3, but the remainder is just simplified. Like, you don't divide the 31 thirds by 3 again, right? Like you divide the 9, the -6, and the 16 by 3. But you're not dividing 31 thirds by 3.
no,
Just putting it over the divisor.
right. But remember, the divisor in this case is x minus a third.
Right.
Right. So really, what we're doing is we're multiplying
Bringing
the
the 3
remainder
out.
by 3,
Yeah.
essentially.
Yeah.
Which makes me question. Oh. That is not what I need. For Pete's sake. Yes, good. That is that. Now it makes me question this one. -4, right? It's -4, yes, that should be -4 times. Is that not being multiplied by 2?
The question of why we didn't multiply the remainder by 1/2.
This one here by 2, so why isn't that negative 1/2? That should be negative 1/2.
I know.
They're all gonna get clickety.
I don't think I can even.
No, everything else is right. It's just this one I'm not quite understanding what's going on. X squared plus 6x minus 4, that'd be negative 1. Should be, yeah, I am not understanding why that's different. Hmm. I write this out. Oh, no, that's not right. That one had,
She asked a question about the very first problem that we did. And then he used this the meeting, and I think he might have did something wrong with the example one. So if
okay, I see. I wasn't careful when I checked my calculator. That should be 31/3. Okay,
31/2.
right. Okay, I see what's going on. Right, everything gets divided. Even that got divided by 3, the remainder. So that should have been 31/9. What I thought originally is that you have to multiply the remainder by it as well. I second guessed myself because that gave me negative. That would have given me negative 1/2 here. Not thinking. So here's how it should look, right? If we write it out. Yeah. Right, this is how this would just look, right? This operation here. If you write it out, but then you have to multiply that entire thing by
So we weren't done.
1/2. That's why it stayed -1. Because then that 2 drops down. It stayed -1 because this already had a common factor of 2. Right, because what happens then when you write this as a proper fraction? Which is the same remainder.
that would be the final answer.
Right, so that's why that remainder stayed as -1. Right, versus here. You look at this, you can't factor out a 3.
(31/9) over x -1, and
Because I skipped an intermediate step then.
then we would multiply just the remainder by 3. No.
Well, no, I multiplied everything by 1/3. including the remainder. Because you can't factor, right, because you can't factor a 3 out of the 16. Right? Which means because that can't be factored out, multiplying by 1/3 isn't going to just cancel out like it did here. Right, look. Here's what's going on. What happens if I factor a 2 out from here?
That's 2.
Yeah, -2. Factor 2 out from 1, you get 1/2. Now I multiplied that whole thing by 1/2, the 2's drop out. And that's where I get the -1 from, because that 2 will just drop down to here. Which is why that remainder didn't change, quote unquote. Versus here, you can't just factor out a 3 because of that 16, which is why the remainder does also get multiplied by 1/3. Because you're technically multiplying everything by 1/2 in the first one and everything by 1/3 in the second. Math does weird things. Because actually, ultimately, what happens is I did factor out a 3, right? 16/3, and what happens when you factor out 3 from 31/3? It becomes 31/9.
All of that.
And then you multiply that whole thing by 1/3, and the 3/3 becomes 1. Knew you multiplied the remainder. So I would just be safe and write it out like I did here in the green. Write it out in this form first, and then multiply by 1/2, or whatever you factored out in the 1/3. Right, so the intermediate step that I skipped there was this step. And multiplied everything by 1/3. That was the step I skipped. Glad I double checked that calculator. Something makes sense. That's why you should never second guess yourself. Let's take a look at another one. To get into proper form, right, we have to factor out a 1/2. And then we're left with what, x plus 1/2? That would make a what? -1/2, right? Then the coefficients for -12, -5, -1. 4 drops down, times -1/2 is -2, minus 12 is -14, times -1/2 is 7, minus 5 is 2, times -1/2 is -1, minus 1 is -2. Here's what I should have been doing. Right? Because what this gives us is this piece right here. Right? Degree is going to be 2. 4x squared minus 14x plus 2 minus 2 over x plus 1/2. Distribute that 1/2 through. 2x squared minus 7x plus 1 minus 2 over 2x plus 1, which is what we wanted.
Gotcha.
So again, it looks like the remainder didn't change, but it actually did. I suppose that's how I'd write it from now on. Just like that. So again, if you actually look at it, that remainder didn't change, did it? Thirty-one thirds. Maybe the remainder doesn't change. You just have to be careful when you rewrite it.
Just scroll down a little bit, yeah.
Down.
Down. No, up.
I understand if it's 2x plus 1, you've got to factor out 2.
Mhm.
So it would be like 2 times the quantity x plus 1/2.
Mhm.
So how does it turn into 1/2 then?
How do you multiply fractions? Straight across, right?
Yeah.
So isn't that the same as? So isn't this
Okay, true. It would be like that same numerator over 2x plus 1. Okay. Okay. Okay.
All right, so that's why I'm just factoring out the 1/2. Wish you could just be safe and use long division. I don't know how you want to do it.
One like a joke. Okay, if you really enjoy the flavor of this one, that's why I do.
Actually, I'm not a fan of M&M's, believe it or not.
Fair enough.
I prefer Reese's Pieces.
Hey, me too, you know, let's go and I'm saying.
Oh, yeah, I'm getting a quiz.
Yeah.
You didn't diss the Phillies because that would have gotten you an F.